A faulty thermostat, a heat miser thermostat. This comes in two modules. The back module has the power switching circuitry and the power supply, and then it's got the electronic module with a memory backup battery on it. And the note that came with this says, please find enclosed one heat miser smart thermostat for your investigatory powers. It had been working fine, then suddenly the display went blank. I've no idea what's wrong with it, but I thought I'd have a quick nosy, hence it's in bits. I suspect the problem lies in the mains power interface, which I managed to separate rather than the display itself. I could have put it back together, but I don't think it would have helped to do so. And this has been prized out. So this module would normally be sitting down in here. And when it's sat in there, this little cover clips in, and then when you actually swing them together, it makes contact with this little connector down here, interfaces of this one. So we can do a quick test on this. I've had a wee look at the circuitry. Let me zoom down on this and we'll take a little look together. For a start, the first thing I looked for was a dome capacitor, and well, there's a dome capacitor. So this is a classic little switchboard power supply and a relay arrangement. And the incoming supply comes in and it doesn't use a bridge rectifier, it uses two diodes in series to create a very crude DC supply. But why are they using two in series? And I thought, well, that's odd. I've seen that before, but why are they doing that? And then I saw the neutral has another diode again, so they've got three diodes in series. Very strange. They're most of the way to a bridge rectifier, but there must be some reason that the manufacturer are putting all these diodes in series. There's a little bit of damage at the edge because, is it George? Let's just double check the name. Roger, actually, it's Roger sent this in, had been leaving it out. It's very easy to damage circuit boards like that when they're in there, but everything's intact. So we have the switchboard power supply based upon those crude diodes, a little filter, a smoothing capacitor, and then the switch mode chip creating its own little supply with this little chip here. And then the output, we've got a diode here going to this capacitor, and then we've got an auxiliary little 7/8 LO5 regulator, which converts to 5 volts. And I'm guessing this is going to be 12 volts because this is a 12 volt relay. And if we also look in the back, we can see there is a protection diode across the relay coil to protect this transistor. And there's a resistor going to the transistor, which means that this module, on this connector, we've got 5 volts, 0 volts, the signal to the relay, and then a couple of sensor inputs, possibly with their own ground. Let's hook a mains connection to this and see if it goes bang. Here is a cable. So there's the live, and then normally open the relay. It looks very robust. They've really gone to town with the isolation slots here. So live is going in there. Make sure I put it into the right place. That would be extremely dramatic. And it would make it a very short video if I put it into the wrong place. No earth connection. And we've got two common neutrals here. So in it goes to one of those. And we'll plug it in and see if it goes bang. If it doesn't go bang, we shall probe it and see what voltages are present. So I'm plugging this in. It's going to be live. That means voltage just... It hasn't gone bang. That's good. I mean, there's plenty of time yet. Let's bring in a meter and set it to the 20 volt range. This is this thing that I often say. Let's zoom it out a little bit. I often say that I always use my meters in the 20 volt range and continuity. It's true. That's almost exclusively it. So let's see if I can do this without shorting things out. So I've got a connection here and a connection here. That should be about 12 volts. It's 5 volts, which wouldn't be enough. That's 5 volts theoretically going into the voltage regulator, and it should be putting 5 volts out. It's not really managing much because that power supply is way low. That should be about 12 volts. So I'm going to guess that capacitor is faulty. Right, tell you what. I'm going to grab a capacitor and we'll swap the capacitor and we'll see what happens if I can find one that's small enough. It's the curse of these power supplies that the little electrolytic capacitors, let's short that capacitor just in case. Hold on. There's the mains capacitor. Is it dead? It's dead. It's fine. Finger test. Yeah, it's dead. It's the curse of these power supplies that because the output capacitor is run at very high frequency, it dissipates a lot of heat because it's seeing current flowing in and out of it really at a very high frequency. It just adds up to a lot of dissipation. If the electrolyte fails, and it has to be a specific electrolyte for that, it causes gas to form inside, which causes the doming and also damages the ability of it to act as a capacitor, so it tends to go a bit odd. So I shall pause momentarily. I shall go and get a capacitor. I'll get the soldering iron on and we'll see if we can fix this. 1 moment, please. Okay, the soldering iron is up to temperature. Sadly, the only capacitor I've got in that rating, the 220 microfarad 50 volt, well, it's 50 volt, low ESR, it's very big. I don't think it's going to fit. I mean, it's no bigger than the main side electrolytic, but it's just going to be potentially a bit tricky to fit in here. I do have a couple of 100 microfarad ones that could be put in parallel, but that's going to be a bit messy. I don't really care much of that. Maybe I should get the right components. But anyway, let's see if we can get this out. And we'll start by zooming down for a start. And I shall flow some solder onto the existing pads of that capacitor, because the solder they'll have used is lead-free solder, and we all know that lead-free solder is just terrible for desoldering. It benefits greatly from some fresh, juicy lead-based solder on it. I could get I could get that low melting point solder that's used for stuff like this. One day I probably will. This is also very hard to grip, this component in the back, so can I use something to help grip this? Can I basically get a bit of blue tack or something? I don't know if this is going to work. I shall put a bit of Julian Eyelet style blue tack on that component, squish it round it just to give me something to grip, and then I'll try and flow both those solder pads at once. No, that has just come off. That has not worked. Let me just keep trying this again. Let me just make a dig of myself by getting nowhere and flow both these solder connections at once and jiggle that little component. Well, I'll tell you what, the blue tack softening, that's a start. It's starting to come out. It's actually reachable now. I can get my fingers on it. Except now it's slightly greasy because of the blue tack. Or white tack, should I say, since it isn't actually blue. Oh, you know what? Let's give myself a wee handle here. I'll use some Captain tape. This is very footery. I'll improvise. And I'll keep making a dig of myself, because this is what happens. Turn a camera on, everything will go wrong. So let's see if I can get this tape onto this component in a very crude manner. It's almost there anyway. It looks as though it's just wanting to come out. This is something I've not really tried before, so if it doesn't work, it's because I haven't tried it before. Right, let's try this. It does feel better. Heat the two solder pads to heat those plated through holes. Alternate back between the two of them until the capacitor pops out. Now comes the way to clear the solder out those holes. I could use the toothpick approach, which works quite well, or I could try the bang it on the table approach, which makes quite a lot of noise, but also works pretty well. You heat the solder up and then you bang it, and theoretically the inertia makes the solder fly out. Those holes are fairly clear now. Is my new big fat ugly capacitor going to fit in? Tricky. I think it may well do. Make sure I get it in the right way around. Oh, you know what? You know what? I think that is going to do just fine. Make sure you check polarity before doing this, just because it helps. Putting the capacitor in the right way around is always a good thing. I shall also be checking it just relative to the adjacent circuitry as well. The middle pin of the little regulator there is the negative pin on a 78L05. Oh, this looks good so far. I'm saying that it may never ever go back into the enclosure again because I've just put a huge fat capacitor in. On a plus note, the higher voltage rating and the higher mass of the capacitor means that it should do better with the ripple. Do we give this a check? Yes, we do. Where's the mains connection again? And we'll power it up. Slight feelings of insecurity. Yeah, that's fine. One always gets feelings of insecurity when one is doing electronic stuff, particularly involving mains voltage. It's quite normal for electricians to be, shall we say, pensive before powering something up, particularly if it's very big and expensive and variable frequency drives come to mind. There's a fantastic video floating around on the internet at the moment on Facebook of a guy doing all his tests before turning the breaker on a variable frequency drive and the thing just detonates. So I've got two neutrals here, common together, so I'll use this one this time. Or maybe I won't because the terminal feels a bit chewed. Is that just spinning? That is just spinning. That is a chewed terminal. It may have been the subject of the wrong type of screwdriver. These things happen. I shall put it into that terminal then. Right, let's turn it on and see if it goes kabim. It may go kabim. I'll sweep all the metal bits out of the way since this is going to wander all over the bench, isn't it? And it's powered up now. Okay, bring in the meter, set it to, well, it is at 20 volt range, my favourite range. I'm expecting closer to 20 volts now. I'm trying to do this without actually getting in the way of the meter. Am I going to get anything here? Am I going to get a connection even? Is this going to need a new... Oh, that is much better. 12 volts is much better. That means I should also get, across this little dinky capacitor, I should get roughly 5 volts. 4.89 is perfectly acceptable for that. Right, I'm going to unplug it now. Always remember to unplug it. You will get caught out that way one day. Right, tell you what. Let's put this little plate over just initially. Is this even going to fit into that module now? Well, I'll find out later on, I guess. And I shall sit it onto the connector. Make sure it's in the right position, because otherwise it's just going to blow everything up and then it would all end in sadness. Right, is this going to power up the display? Is it going to do anything? I rather think it is. It's displaying dashes as the room temperature because there is no thermostat sensor connected to it, I would guess. Oh, there we go. 22 degrees Celsius. Luxurious for in here, but it has no external sensors set up. Oh, the touch thing does work and it lights up. I would say, to be honest, that's probably it fixed. Right, well, that was a success. Now the question is, will it fit back into the original thing? So I shall just bridge that capacitor, because there is a spice capacitor there. There's a one that is prone to causing much pain, and it's that electrolytic capacitor there. It's discharged, that's fine. Finger test for confirmation, yes, that's correct. And we'll see if it fits back in here. It is the moment of truth. Drop it in here. Observe the chew marks from Roger's activity. Have I got that name right again? Yes, I did get it right. It is Roger. And is this going to click back in? Oh, you know what? Does the circuit board, does this just pack against the circuit board, or does it actually clip under bits? Not really sure. Mumble, mumble, mumble. Talking to myself. Will this clip in at all? Is this how it goes in? Am I supposed to put it into that first? I think I might have to put that into that first. No, I think it just spaces like that. Yeah, this is all kind of just faffing around now, isn't it? Is that going to click down? I think the circuit board's gone down far enough. It's just, yeah, that's it. Loud poppy clicking noises, that's going to sound great. And that is presumably, oh, that does make together quite well. That's presumably it. So, yes, that is it fixed. So if you have one of these and it suddenly dies, this applies to so many things. The first suspect is these little capacitors. I mean, what's it even like inside? I don't think there'd be anything visible inside, would there? Shall we open it up? Yes, we shall. Let's just randomly open it up with random chemicals all over my fingers and see what it looks like inside. There's a little seal at the bottom. It might be completely dry. When they get hot, they sometimes squish all the electrolyte out. Oh, it looks fairly dry inside. I think that's it. I think it's just basically, it's vented, the pressure's built up and it's basically squirted all its juice out and it's dry. Yeah, that feels very dry. And that's why the capacitor is dead. Let's unravel it. Let's go all the way with this because we can. Where's a knife? Where is a knife? Where is my knife? I've misplaced my knife. Not to worry. I shall use this in a very crude knife-like manner to slit at that tape. That's not going to work, is it? This is unprofessional. Yes, it is. It's what you've come to expect in this channel. Unprofessionalism. So here is our foil. I've just stabbed myself in the solder connection. Oh, it's a bit crumbly. I mean, I suppose it's justified in being crumbly. Oh, that's one of the sort of tab connections, and then it's the other part of the foil. Yeah, that is absolutely dry. Just basically the wicking material for the electrolyte separating the aluminum foils inside metal foils. But there we go. The fix is done, and that is more or less it. So if you have one of these, first suspect is look for those domed capacitors on top, because that's what happens. The pressure builds up. It's the sign that they're going to vent their electrolyte, or that bubbles have formed and it's diminished their capacity. It's a very cheap and easy fix, but you have to use the low ESR capacitors, the ones suited to a very high frequency ripple current, because the switch mode power supplies are really quite heavy on them. But there we go. Good fix.